So I find that some details are missed in the video, so I will record these videos in order to make you know how to do the homework. So first, so if you have two protons and two neutrons, so if you combine them together, then you will get the helium. Okay, and so after the calculation, then you will find that the mass of the helium is smaller than the mass of these four particles. Okay, so there is delta M here, and you can convert the delta M into energy. So actually, the mass listed is actually becomes the energies between the nucleons, what we call the binding energy. So the binding energy is used to combine these four particles together to make the nucleus stable. So in the other words, the higher the binding energy per nucleon, okay, so we call neutron and proton as the nucleon. Okay, so the nucleon, the numbers of nucleons is 4 here. If the binding energies per nucleon is higher, then the particles is called more stable. Okay, so for the calculations about how to find the binding energies, then you can see the video that I sent you. And what I really want to tell you is the diagram here. So first, draw the coordinates. So the x-axis is the atomic number, and the y-axis is the binding energy per nucleon. Okay, so that means how much energy is carried by one nucleon. And so for the atomic numbers, equals to 1, which is hydrogen, equals to 2 is helium, so 26 is iron, and blah 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 uranium. So I forgot the atomic numbers of the uranium, but it doesn't matter. Okay, so if you plot the diagrams like this, then you will find this pattern. Whoops. Okay, so the binding energies per nucleon for iron is highest. Okay, so which is lowered for the other elements. So if you have a hydrogen, then it will try to increase its atomic number. So how can the element increase its atomic number? Then it can go under the fusion. So different lighter nucleus combined with each other, then increase its atomic mass, and which we call fusion. And then for the particles which are heavier than the iron, then it will undergo fission. Okay, so for particles undergo fission, then it will become lighter element. So think about this. So those particles will try to become iron because it's more stable. This is the reason why after the star dies, it becomes the white dwarf, black dwarf, and finally it becomes the iron ball floating into the universe, because the nucleus of iron is the most stable one among all elements. Okay, and so in this case, we know that what is the physical stable. Okay, so when we talk about stable in physics, normally we are talking about the nucleus. You can think about this. Iron is actually quite active in the chemical reactions because it's easy to lose its electrons and combine with other elements. Okay, so to form a compound. However, in physics, the nucleus of iron is very stable. It's difficult to change into the other elements. Okay, so this is the difference between the active in physics and chemistry. In chemistry, we are talking about the reactions between different elements. However, in physics, when we talk about stable, it's the stabilities of the nucleus. Okay, so if it is hard to undergo fusion and fission, then it's called stable. So for the particles, for the element which is lighter than the iron, then it will undergo fusions until it becomes iron. So for the element which is heavier than the iron, then it is going to have the fission and then it becomes iron. So at last, so our universe will be full of iron. Okay, so of course after millions years later, then we have only protons, neutrons, and electrons.